Hi everyone, this is Sakshi. So today I'll be teaching you ultrasound. Before that session, I want to introduce myself a little bit. So I myself is a government employee. Also, I'm doing PhD in radiology itself. I have done my masters. After that, I enrolled for PhD part time, and right now a government employee at AIMS only. So see, as every year, this time also I am teaching for CRE to many students, many of my known to students. So this time also I am doing, and just to get an idea about me, I have also guided many more students, also my juniors from the college. And to be very proud, I would like to tell you that many people have qualified the exams. I myself has qualified this AMCRE, what say that Delhi State Board exam, Bihar State Board exam, and previously I have qualified this AIMS Bhubaneswar. I have done from my bachelor's from. I was a student at Super 30. Super 30 you might be knowing, right? IIT JAM I've qualified. So many more exams I have appeared for and qualified also. So that is why I find myself a very appropriate person to get you through competitive examination. That CR is also one of the example. So see, since I am from a radiology background, I can be the best person to teach you for this CRE which is upcoming in the month of July. So I expect from you guys to trust me and trust the process and also trust your preparation. So today we will be starting with ultrasound. So if I talk about ultrasound, see, many times what we have seen in the X-ray machine, you might have seen it in the ultrasound also. You might other modalities also are there like MRI, different DSA procedures and fluoroscopy and many more things we have seen. So mostly what we have seen is X-ray. So X-ray were put to the practical use the moment they were discovered, that you already know, right? And day by day many improvements have been made in the techniques, which progressed rapidly during the first few years, and then it settled down. Now also it is developing, but as compared to that, ultrasound has been notoriously slow, very slow in the medical evolution. But I would like to tell you one thing, that this is the best because they are not harming you, right, in any way. Also for pregnant ladies this is the best because that's not having the, let's say, radiation. So the technology for producing ultrasound and the characteristics of the sonic waves have been known for many years. Obviously everybody knows that. The first major attempt at a practical application was made in a very unsuccessful search of the Titanic, in North Atlantic, which was in 1912. So at that time, many earlier attempts were also made at applying the ultrasound to medical diagnosis. At that time, a little bit, success happened, but with time, it happened very gradually, very beautifully, you would say. So techniques at that time, what we were utilizing were not sufficiently developed, and especially the imaging techniques, until the massive military research effort that happened during the World War II. That time sonar, that is sound navigation and ranging, were put to use. This was the first, I would say, most successful application that was made at that time. So successful medical applications after that began shortly after the war, and in the 1940s, early 1950s, that time it was very rapid. So before starting to tell you more about the ultrasound, let us know a bit about the characteristic of sound waves, right? So a sound wave is a very similar to an X-ray beam, very much similar. Obviously they are both are put to practical use for knowing what is exactly going on inside your body, human body, right? So a sound beam is similar to an X-ray beam in that both are waves, both are transmitting energy, right? Very important difference between the two is that the X-rays will pass readily through a vacuum, whereas if we talk about the sound, it's not exactly the same. It does require a medium to flow, to pass for its transmission. So the velocity of sound will depend on the nature of the media. A useful way to picture the matter, that is the medium, is as a series of spherical particles representing either atoms or molecules, which is being separated by the tiny springs. Suppose you have pushed the first particle, so it will push the second particle, it will move, it will compress the attached spring, and thus they will exert a force on the adjacent particle, and this will set up a chain reactions. Okay, this will set up a chain reaction, but every subsequent particle will move a little less than its neighbor, because that was the exactly main point where the exact actual force was applied. Afterwards it will diminish, right? That's why it is little less. So the tension or the pressure which is being applied to the spring is greatest where? Between the first two particles. That you understand properly right now. And it becomes less between any two down the line. So if the driving force reverses its direction, the particles also reverse their direction. And if the force vibrates to and fro like a cymbal that has been struck, the particles respond by oscillating back and forth. So the particles in a sound beam behave in the same manner, that is, they oscillate back and forth, but over a short distance of only a few microns. So the distance is very important for CRE. They can ask you one question, they'll give you options, because CRE now is mostly, because the cutoff is getting higher, right? So they are mostly focusing on those questions which can easily get them negative from the students. So what you have to do, you have to read it properly to reduce your negative marking, right? And there will be very silly questions which will give you negative. Got it? So this much I want to teach you today. From tomorrow, since the session has already started, today I am sharing this video by recording this also to the students who are not in that session, just to know me better. Also I would like to share with you various links in which I have taught various other topics. So please get through it, learn through it, learn, understand, and ask doubts also. Thank you for listening. Bye.